Hello guys and welcome back to my video. In this video I'm be talking about Scikit-Learn pipelines. So Scikit-Learn pipelines is a class that allows us to encapsulate all our transformations and our final estimator. So what the pipeline does is applies a list of transforms and final estimator, and the intermediate step of a pipeline must implement fit and transform method, and the final estimator only needs to implement the fit. So what does is pipeline class is also similar to other scikit-learn classes that we've seen, such as the support vector machines and so forth. They all have similarities. As you can see that the scikit-learn pipeline also has the fit, the predict and score, just like any other estimator that we use using the scikit-learn library. So the step parameter for the pipeline must be a tuple consisting of a name and an instance of the final estimator. So what the estimator does, what the pipeline does, it makes us easier for us to fit our classifiers. So let's say we want to create a model. Let's say maybe to want to create a model. Let's say to predict fraudulent transactions in credit cards. So as a machine learning engineer, as you'll be developing this model, there's a chance that you want to test different models. Let's say, for example, you want to test your data on the support vector machine, logistic regression, the k nearest neighbor, gradient boosted trees, and other traditional machine learning models. So what you do is the pipeline allows us to fit estimators such as the standard scalar, or like principal component analysis that we use to decompose dimensions. So the principal component analysis works just, let's say if we have data that is like 30 dimensions, the principal component analysis allows us to break that data into something which is simple, let's say two dimensions. So that's what the pipeline does. So now I'll walk you through the code and explain how to implement the pipeline in scikit-learn. So just know that the pipeline is just an encapsulator that makes us easy for us to fit all our estimators, such as the standard scalar like principal component analysis, like grid search for improving our parameters for different models. So the first thing is we import the iris dataset from scikit-learn, and then the next thing is we import the we import train test plate from scikit-learn model selection. We also import from the scikit-learn preprocessing. We also implement the standard scalar. So what the standard scalar does is that in our dataset we have different we have different features. So these features have different values. Some features have way big values than other features. So what the standard scalar does is that it subtracts each feature. Let's say it subtracts the value of x, let's say from the mean, and then it then divides that value by the standard deviation. So if we apply standard scalar, we find that all our data set maybe will be falling along the same range. So we want our data set to be following along the same range, so that our model will not be confused. We also, from scikit-learn decomposition, we also implement the principal component analysis, which is PCA, which I've also talked about. We also implement the pipeline. We also implement the pipeline instance, or the pipeline class from scikit-learn pipeline. We also implement the job lib. Which we are going to use to dump our sklearn final model, so that we may use it maybe for production. Maybe if you want to create a web application, or you want to deploy it into maybe an Internet of Thing application. So our first model, we are going to from linear model we are going to import our logistic regression model, and then from scikit-learn.ensemble we're going to implement the other boost classifier and the gradient boosting classifier. So what the other so ensemble is just these are a group of models that have been grouped together, so that each model learns from the mistake that is made by another model. And then from scikit-learn.neighbors, we also implement the k nearest neighbor class. And then we also implement the support vector machine. So the first step is So the first step is we load our data, we initialize our data set. So iris is equals to load iris. And then the next step is we are going to split our data set into training and test set. So here we have the x value for the train set, x value for the test set, y value for the train set, y value for the test set. And then which is equal to, and then we initialize this class, the train test split, and then we provide the first parameter should be our features. So in this case, this is iris.data, and then the next value should be our labels or our target, which is iris.target. And then we want to split our data set. We want to split our data set, 20% of our data set into test set, and then 80% of our data set into training set. So this test set parameter allows us to split our data set. Allows us to split our data set into a test set. So we provide 0.2, which is 20% of our data set, and then we randomize our data set. So here we are going to initialize the pipeline class. So the pipeline class takes in a class. The pipeline class takes in a parameter of steps. So the step parameter for pipeline must be a tuple consisting of a name and an instance of the transformer. As you can see here, the step parameter for the pipeline must be a tuple consisting of a name and an instance of the parameter or estimator. So as you can see here, we initialize the pipeline LR, which is for logistic regression, and then we initialize the pipeline class. We then provide a tuple. If you remember what I said the first thing is the name of the estimate, is the name of the transformer or the estimator class. Here the name is SCO, which is standard scalar. Here we provide the tuple S name SCO, and then provide the transformer, which is the standard scalar. Here it's PCA, which is principal component analysis, and then we initialize the transformer, which is PCA, and then we want our number of dimensions or number of components to be 2. So this is the parameter n components is equals to 2. CLF, which is our classifier or our estimator, is we initialize it as logistic regression. We randomize it to 42. The next thing is we create also a pipeline step for the support vector machine, and then we initialize the pipeline class, and then we provide this tuple. We first provide the name of the transformer, which is SCO, which is standard scalar. We initialize the standard scalar class, as you can see. The next thing is we also provide the name of the transformer, which is the principal component analysis. We provide the instance of the class of the principal component analysis. The number of components is equal to 2. Also, now here we put the final class, the name of the estimator, CLF, which is support vector machine dot support vector classifier. We randomize it to 42. The next step is we create a variable for the step for the decision tree pipeline. We initialize the pipeline class. We also do the same thing. We start with the name of the transformer, which is standard scalar. We initialize the standard scalar class. We also put the name of the next transformer, which is the principal component analysis, which is PCA. We initialize the PCA. Number of components is equals to 2. The third part is we initialize our estimator, which is CLF, and then we initialize the decision tree classifier class. We randomize it to 42. The next thing is we also create a step for the other boost algorithm. We initialize the class as we have done above. Provide the first name of the transformer. We initialize the class of the transformer, which is standard scalar. We do the same thing for the principal component analysis. We first provide the name. We initialize the class or the instance of the principal component analysis. We provide the number of components, which is 2. Now we provide the name of the estimator. We initialize the class of the estimator, which is other boost. We do the same thing for the gradient boosting algorithm, and we also do the same thing for the k nearest neighbor algorithm. Now the next step is we create a list of pipelines so that we can easily iterate through them. So what we do here, we create an array or a list. This array, we call it pipelines. We first provide the pipeline step, or first provide the pipeline step for the logistic regression, the pipeline step for the support vector machine, pipeline step for the decision tree, pipeline step for the other boost, pipeline step for gradient boosting, pipeline step for k-nearest neighbor. And then we then create a dictionary of pipelines and classifier type for ease reference. So our first, here the key, here the key here is 0. The value is logistic regression. The second key is 1. The value is support vector machine. The third key is 2. The value is decision tree. The fourth key is 3, and the value is other boost classifier. The fifth key is 4, and the value is gradient boosting. Now we iterate through the array that we have created, this array. We iterate through this array. So now, instead, what I really like about this pipeline is, let's say for instance we created different classifiers. Let's say we initialize different classifiers, let's say for other boost, support vector machine, decision trees, and so forth. That means that we would need to fit our data set separately for each estimator. So what I like about the pipeline is that instead of fitting our data set separately for each estimator, what the pipeline does is we only need to fit our data set into the pipeline, and this pipeline will now fit our data set in all our estimators. So this is how the pipeline makes it easier for us as machine learning developers to create machine learning pipelines or project. It encapsulates the whole process of repeating some of the things, and makes it easier for us to just fit something once, and it will be fit on all our classifiers. As you can see here, we iterate through our pipelines list, this list that we've created, and then we fit our dataset into the our pipeline list. So that means that our dataset will be fit to the logistic regression algorithm, support vector machine, decision tree, other boost, gradient boosting, and k-nearest neighbor. And now the second step is we need to compare accuracies. So what we just do is we just loop through the pipelines. As I've said, that the pipeline is all the methods, such as other estimators, such as score. As you can see that the logistic regression algorithm has an accuracy of 93.3. Support vector machine has an accuracy of 90.0. Decision tree pipeline has a test accuracy of 87%. Other boost pipeline test accuracy of 0.60. Gradient boosting pipeline a test of 87%. The k nearest neighbor is a test accuracy of 93.3%, which is also the same as the logistic regression algorithm. Now we want to identify the most accurate model on our test data. So let's say, like I've said in the beginning of the video, let's say we're creating an application, let's say for a bank, to detect fraudulent transactions. Now after fitting all your models and after doing all the pre-processing, now the final step will be you want to choose which model is best so that you can use that model for production. So you can see here, we first initialize best accuracy with 0, best classifier with 0, best pipeline as a string, and then we loop through the pipelines, and then if the value dot score is greater than the best accuracy, then we want the best accuracy to be the value dot score, and then we feed our test set, and then we set the best pipeline variable that we have created to this value, and then we best classifier to this index, and then we print the classifier with the best accuracy. After that, we save the pipeline to file, or we then save the pipeline to disk, so that you can use that for production. So now that I have explained, I'll just run this code so that you can see what is happening. As you can see that cluster with the best accuracy is the logistic regression. So thanks guys for watching and tuning in to my video. So I'll put the link in the description for the code, for the GitHub repo that is the code that I've used. Thanks for watching guys. Cheers. So in the next video I might talk about how to fit the grid search or the K-fold for improving the accuracy of our models. Thanks for tuning in guys. Cheers.